So today we will do an extension of the Cournot Duopoly model where we shall incorporate a fixed cost component in the Cournot model and see how does this affect the model outcomes. So as usual we are starting with a linear inverse demand function which is given as price at quantity Q is going to be alpha minus Q if Q is less than equal to alpha and 0 if Q is greater than alpha. If you haven't done Cournot model yet, please go on the link I will be providing in the description and have a look at the Cournot model first. So we have two forms which are I and J, or you can call them 1 and 2, doesn't matter. The cost function for each of the form is this is given as Ci Qi 0 if Qi is 0. If no quantity is being produced, the cost is 0. F plus Cqi if Qi is greater than 0. So you see that we now have our additional component which is F. So this component is new thing here, that is the fixed cost. Okay, so now we will try to find the Nash equilibrium. So first form I's profit maximization function will be given like this: pi I, this will be 0 if Qi is 0. If the firm is not producing at all, then there is no scope of any profit. Uh, if it is producing something, then it is Qi into P when the quantities are actually summation of I and J minus the cost, average cost, minus the fixed cost if Qi is greater than 0. So again understand, this part was something usual that you were seeing earlier also. The new thing is in here, this part. So this F is again the fixed cost that we are bringing in here. So it should not look that this is the part of, so okay. So this is the extra thing. Now we will simply expand these, uh, right? Let's say this pi I is nothing but pi 1. So this is going to be Q1 alpha minus Q1 minus Q2. This was actually P1 Q1 plus Q2 in bracket. So I removed the bracket, so sign changed to negative. C minus the fixed cost component F. So this we can further expand this. So this becomes alpha Q1 minus Q1 square minus Q1 Q2 minus C Q1 minus F. Now we will take the first derivative of this and set it equal to 0. So we are going to do this del pi 1 by del q1. So this is going to be alpha minus 2q1 minus q2 minus c, and this part f will actually become 0. so that's omitted, is equal to 0. So from here we can actually find that this is Q1 is equal to alpha minus Q2 minus C by 2. So this is your first equation of interest. Because the forms are symmetric, so we will have Q2 is equal to alpha minus Q1 minus C by 2. So this is second equation of interest. Now we solve them simultaneously to get the value of Q1 and Q2. So what we are going to do, we substitute the value of Q1 in terms of Q2, sorry, the value of Q2 in terms of Q1 in the equation for Q1. So this is going to be alpha minus, this is the value of Q2 that we have replaced in place of Q2. Okay, so this is now further expand this, you get half 2 alpha minus alpha plus Q1 plus C minus 2C by 2. So this becomes 1 by 4. We will strike off this, this, this and this. So this will be 1 by 4 alpha plus Q1 minus C. This is equal to this Q1. So what we are going to do, we are going to take this becomes 4Q1 and we take this Q1 this side, so this becomes minus Q1 is equal to alpha minus C, or we will get Q1 star is equal to alpha minus C by 3, and this is nothing but the simple Cournot model outcome. So you see that fixed cost does not have any impact on the quantity choice of the form. Okay, so similarly, because the forms are symmetric, Q2 star will also be alpha minus C by 3. So these are the two things that we got for our Nash equilibrium. So now what does the role a fixed cost play here? Does it have any role at all? Yes, it has. It helps firm deciding whether it should produce or not produce altogether. So how does it do? So let me write this fixed cost. No role in equilibrium. Decides the firm should produce or not. So now we realize that in equilibrium this is not going to help, so fine. Now we shall focus on this part, that how does this actually decide that whether the firm should produce or not. So we shall now do that. So first we have to look at the profit part before we reach there. I1 is equal to alpha minus C minus q2 by 2 into alpha minus c minus alpha minus c minus q2 by 2 minus q2 minus f. So there is nothing complicated here. Just try to understand. This part is nothing but your q1 part. This is this was actually alpha minus q1 minus q2 minus c. So you see that this part is alpha, this is q2, and this is the value of q1 in terms of q2, and this is the c. So everything is same, so nothing to worry about. Let's expand this further. So this is alpha minus c minus q2 by 2. This we will expand. So this is 2 alpha minus 2c minus alpha plus c and plus q2 minus 2q2 by 2 minus f. So you see that this negative f part is always outside. This is not directly entering the system, but this is just subtracted, because whether the form produces 1 unit, 10 unit, or not produce any unit at all, f is done once, so it is done. So now we shall strike off the common things. So this is by this removes this, and this is done by like this. So this now becomes alpha minus c minus q2 by 2 into again alpha minus c minus q2 by 2 minus f. So basically this entire thing becomes alpha minus c minus q2 by 2 whole square minus f, and f is the fixed cost again. So this is the equation for profit for the form 1. So find this is equal to pi 1. Now we know that this profit of the form 1 pi 1 will be, sorry for this, will be non-negative if the following condition holds. What condition? Alpha minus c minus q2 by 2 whole square is greater than the fixed cost f. So if this condition holds, then we know that the profits are going to be positive. Okay, so we actually now tweak this everything to write that in terms of q2. So r if q2 is less than equal to alpha minus c minus 2 square root f. I just I have removed this square sign. So then this I have to put if I remove this square sign, then I have to put this into square root, and then 2 will go on this side, this 2, and you know that we can solve for it like this. So now we are going to put a smaller indicator for this particular value that we have got, alpha minus c minus 2 square root f. So let q bar is equal to alpha minus c minus 2 square root f. Okay, so now we can actually write the best response function of the form. So how do we write? The BR1 shall be, how it will be? I am writing B1 Q2. Best response of form 1 against the quantity choice of the form 2. So there will be 3 points. First, it will produce half alpha minus C minus Q2 if Q2 is less than Q bar. Because if Q2 is equal to Q bar, then profits will not be positive. So it can produce 0 or half alpha minus C minus Q2 if Q2 is exactly equal to Q bar. We will talk about this later. 0 if Q2 is greater than Q bar. So if form 2 itself is producing more than what is required in the market for the profits of the form 1 to be positive, then form 1 is better producing 0. If form 2 is producing less than this particular output, then form 1 should produce a best response to this. This is this. Now comes this question of this. When Q2 is exactly equal to Q bar. So see what will happen here. We are saying that one response is don't produce anything. Another response is produce this. So how do we believe that these two are responses? So let's do some back of the envelope calculation. So we are going to do this here. So if Q2 is equal to Q bar, then I1 is going to be alpha minus C minus alpha minus C minus 2 square root F by 2, and this is whole square minus F. So what is going to happen here is this, that we will end up striking off this will be alpha minus C minus alpha plus C plus 2 square root F by 2 whole square minus F. So this will be struck off, this will be struck off. So what is remaining is this, pi 1 is equal to 2 square root F by 2 whole square minus F. Now let's expand this particular expression. So this becomes 4F divided by 4 minus F. So this 4 cancels out, this cancels out. What is remaining is 0. So you see that form 1 will get 0 whether it produces this particular value or it produces nothing. Either way it is getting only 0, and any player will be indifferent between action choices which give the same outcome. So for form 1, profits are always going to be 0 whether it produces nothing or it produces this, profits are 0 when this Q2 is exactly equal to Q bar. So this is the best response function for the form 1. So now we realize that the best response function of the form 1 has a jump. It can either produce 0 or it can produce this. This particular thing is definitely a positive quantity and greater than 0. So there is going to be a jump. So what happens? So see, uh, therefore, best response perform 1 has a jump. And where does the jump occur? For Q2, slightly less, any epsilon slightly less than Q bar. Uh, Best response for form 1 is that produce Q1 greater than 0. But for Q2, any epsilon more than Q bar slightly greater than Q bar, form 1 should not produce anything. It should produce 0. So there is a jump because the forms are symmetric. So this is same the case with the best response function of the form 2 also. Now we realize that this q is nothing but this q is written q bar. This q bar is nothing but alpha minus c minus 2 square root f, and we are interested in understanding the role of the fixed cost. So on the basis of this f thing, that is the fixed cost, we can have four qualitatively different cases of equilibriums. So let us see them. So there are total four cases based on f. So case 1, if f, this fixed cost, is small enough, so so that the following condition holds: q bar is greater than alpha minus c by 2. So what is actually alpha minus c by 2? If you remember, this is nothing but monopoly output. And because we are interested into discussing in terms of f, so we can convert this expression into terms of f also, or f is less than alpha minus c whole square by 16. So how do we get this particular value? Let's do again that back of envelope calculation. So see, we will start like this. If q bar is greater than alpha minus c by 2, then we write the value of q bar alpha minus c minus 2 square root f is greater than half alpha minus c. We can bring alpha minus c at one side, so this is alpha minus c minus half alpha minus c. This should be greater than 2 square root f. So then we realize that this becomes half alpha minus c is greater than 2 square root f. This can also be written as 1 by 4 alpha minus c is greater than square root f, or we can simply square both the sides. So this will become sorry, This will be alpha minus c whole square, and 4 square is 16, is greater than f. That is exactly what we were claiming, right? So see this particular thing that we got. So fine. So now is the time to plot this and see that how the best responses will behave. So I'm going to plot it now. So this is the axis along which I will show Q1. This is the axis for Q2. And now let's label them Q1. Oops. This is Q1. This is Q2. This particular output is alpha minus c by 2. Here we will have alpha minus c, beyond which there is no production. Here again alpha minus c. This is alpha minus c by 2. So now let's plot them. So hopefully we will do it right. So what I am going to do, I will take different colors. So let's take one this color, and okay, I will take one this color for B1. So see what is going to happen. We will have we needed to put our Q bar also. So Q bar was supposed to be greater than half alpha. So our Q bar can be somewhere in this range. So let's say Q bar is here. This is Q bar. Similarly, we will have a Q bar for this axis also, Q bar. Now let's do this. So see, we are starting from here like this, and we will go up to Q bar. Okay, and then we will stop. Why shall we stop? Because the next part of the best response is going to coincide here. So see, let me make it more precise. Yes. So this is your B1 Q2. This is also B1 Q2. So see, the form 1 can produce monopoly output if form 2 is producing nothing but 0, or it can produce along this best response function. But the moment Q2 reaches Q bar, the form 1 can produce 0 output, okay, or it can produce an output that matches this particular portion of the best response. Both of these are going to give it the same level of profits. Now for the other form, so it will again go like this. So we shall start from here, go like this. We need to move it little. So let's move it like this. Yes. And then we can extend it up to Q bar, right? And then beyond Q bar, this is going to be like this. So both these are part of best response function of the form 2, best response of form 2 against the output choice of form 1, B2, Q1. Now you notice that we have got an intersection here. So let's draw a line from here. Okay, we need it little bit. Okay, sorry for my perfectionism. We are done. Now this will come to this side like this. Again, this needs to go little bit up. Yeah, so this is done. So what is this? This is nothing but your Cournot output alpha minus c by 3 alpha minus c by 3. Okay, so this is the Nash equilibrium also. Alpha minus c by 3 comma alpha minus c by 3. This is the Nash equilibrium. So you see that there is no impact of the fixed cost as of now in this particular case, because the fixed cost was small enough to be less than alpha minus c whole square by 16, or q bar was greater than the monopoly output. Okay, so here we have no impact of fixed cost. Now come to the second qualitative case, which is when we are having our f, we further increase f. So what is going to happen? So you see that as f is increasing, okay, so the point where the best response function has a jump or a discontinuity, this moves closer to origin. Why? Because I will show that why q bar is decreasing. Why? Because q bar is nothing but alpha minus c minus 2 square root f. Now, if this part is increasing, the value of this part will decrease. So as f is increasing, we shall move closer to the axis. So now again, let's plot this. So, okay, I need axis again. So this is how far I can go to here. Let's expand it. So this is again Q1. Oh. Similarly, I need one axis on this side. Okay. So now this is Q1, this is Q2. So we will again have our usual notations. So this is alpha minus c by 2. So see, now we have our best response function for the form 1. So this is this line, and then here we have q bar that gives the discontinuity. After this, best response function of the form 1 is here. Similarly, for the form 2, it is up to here, then discontinuity at q bar, and then this green line extends up to here. So this is the best response function for the form 2. And you notice that the Q bar is in the range of monopoly output and Cournot duopoly output. So between alpha minus c by 2 and alpha minus c by 3. So this is the range we are talking about. So in this we can see that there are three Nash equilibriums. One will be our usual one, this position where both best response functions are intersecting each other. So we get this is alpha minus c by 3 and alpha minus c by 3. Always remember the first output is about the first form and the second one is for the second form. Similarly here this second Nash equilibrium, here form 1 is producing monopoly output while form 2 is producing 0. So this is intersection of, this is the best response function of the form 1, this is for the form 2, and they have one common point here. So here you see that form 2 is actually form 1 is producing monopoly output while form 2 is producing 0 output. On this axis output for the form 2 is 0. So this is this Nash equilibrium. The third Nash equilibrium is where the form 1 is producing 0 while form 2 is producing monopoly output. So you see that this is this point. Here the best response function of the form 1, this part is this is the best response function of the form 2, the green one, and this orange one is the best response function of the form 1. They have one common point here at alpha minus c by 2. So form 1 is producing 0 along this axis. Output for form 1 is 0, so 0, while form 2 is producing this monopoly outcome. So we have these three Nash equilibriums here in this situation. When Q bar is between alpha minus c by 2 and alpha minus c by 3, then we are going to have these typical Nash equilibriums. Okay, so and we can also rewrite this condition, this particular condition, in terms of f as usual, some back of envelope calculation. So if q bar is less than alpha minus c by 3, then we will have alpha minus c minus 2 square root f is less than alpha minus c by 3, or alpha minus c minus alpha minus c by 3, this is greater than 2 square root f, or we will have 2 by 3 alpha minus c is greater than 2 square root f. So we shall strike off these 2 and then square both the sides. So alpha minus c whole square by 9 is greater than f. So this is the condition. So you see that for alpha minus c by 2, we already had f should be less than, f should be greater than alpha minus c whole square. So let's write it here rather than doing that. So this alpha minus c whole square by 16, this is less than f, and which is less than alpha minus c whole square by 9. So this is the situation when one form shall produce the monopoly output while the other form shall produce 0, or both forms can produce Cournot outcome. Okay, so now the third case, sorry, so third case, as f further increases, so there will be a point as f increases even more, uh, at a point Q bar will be less than the monopoly, this oligopoly output, but greater than 0. So I can actually say like this. Q bar is greater than 0 but less than the oligopoly output. Okay. So what is going to happen here? So this will actually be nothing but this will be alpha minus c whole square by 9. This we have already seen. This is uh, less than f, which is less than alpha minus c whole square by 4. So this you can derive as a practice, or I can do that if you don't want to do practice. But for now, try once. Q greater than 0 means alpha minus c minus 2 square root f is greater than 0, or alpha minus c is greater than 2 square root f, or alpha minus c square by 4 is greater than f. That is what we were claiming there. So what happens here? The functions become even more interesting. So let's plot them and see. So this is again q1, q2, 0. So here I have now alpha minus c by 3. This is alpha minus c by 2. And q bar is somewhere here. Again, q bar is somewhere here, which is even less than alpha minus c by 3. And this is alpha minus c by 2. Okay, so how the best responses will behave? So it will be like this. We will start with the best response function of the form 1, like this. Oh no, like this, and stop exactly at q bar. After that, this will be like this. Similarly, for the other form, this will be starting from here. This will start from here like this and stop at the point of q bar. And the remaining part will be on this side from here to here. Okay, so now let's name them. So this is B1 Q2, B1 Q2, B2 Q1, B2 Q1. So this becomes even more interesting. Now we have only two Nash equilibriums. See, uh, our earlier choice, that intersection of both these somewhere here inside here, used to give us this Cournot outcome, but we realized that Cournot outcome is no more possible. We have only one situation when form 2 is producing the monopoly output while form is producing 0, or when form 1 is producing monopoly output and form 2 is producing 0. So one situation, form 1 is producing monopoly, form 2 is producing 0. The other is form 1 is producing 0, form 2 is producing monopoly output. आ गया? हाँ ठीक है. So now you see that the usual oligopoly outcome of alpha minus c by 3 is no more available. Why? Because the fixed cost is very high. Imagine a situation where uh, all the fixed cost is also sunk cost. Sunk cost is fixed cost can be of two types. One where we can recover some part of fixed cost, but some will be lost. So whatever we can recover, that is normal fixed cost, and what we cannot recover is sunk cost. So imagine a situation where majority of the fixed cost is actually in part of sunk cost. So you see that fixed cost is so high. So now what is going to happen that we are uh, the firms will be skeptic to enter the market because they cannot just dissolve their investment and recover all the fixed cost. So here the only outcome will be a monopoly. Okay. So now the extreme of all this, the last case, D, if f is extremely large, if f is extremely large, let's say it's reaching towards infinity, then no firm will actually want to produce any output, even if the other firm is producing no output. Okay, so what is going to happen when f is greater than alpha minus c whole square by 4, then unique Nash equilibrium will happen, which is 0, 0. So Q1 star is 0, Q2 star is 0. No firm wants to produce any quantity because F is enormous. So you can now understand the economic significance of this. This is the case of social overhead capitals. Here the F is so large, they have to invest so much in fixed cost and nothing of that is recoverable, that no private firm will try to enter that particular market. So what happens here? The government has to move forward and provide production. Otherwise, left to private, there will be no output. So we saw that the Cournot model in presence of fixed cost interestingly affects firms' decision whether to produce or not to produce. And depending on the level of fixed cost, we may see different Nash equilibriums. So hopefully you understood this. If you like it, please comment. You can ask questions also if you have. And thanks and bye.